Alright, so how do we perform Euclidean distance on our landmark data? This will give us another set of variables or features, shape variables or features we are going to be using for analysis or for classification. Euclidean distance is very powerful because it could be used as either for analysis sake or for classification sake. Because if you are going to use it for analysis, then you need to select few biological landmarks to perform your Euclidean distance on. You not want to perform it on all the landmarks data, because it will generate a lot of data for you automatically, a lot of features for you, so which you may not be able to analyze properly. So you need only few landmarks data, which is called anatomical landmark, few of them to perform your Euclidean distance. But if you want to use it for classification purpose, then you need a lot of data. So we can use all the anatomical landmarks or all the landmarks, both anatomical and semi-landmarks. So let us go back to our template again, how it look like. Let's say we have a template like this, for example, which we designed the other time, if you still remember very well. Okay, now this template that it is now, we have the red ones anatomical landmarks, while the blue ones are semi-landmarks, which we slit on the face, on the surface. Now, if you want to perform Euclidean distance, it means we want to find the distance between this point and this point. This is exocanton to endocanton. Want to find the distance, or want to find from here to here. Okay, binoculars. We want to find from here to here. Okay, we want to find from here to here. How long is their nose from here to here? All right. We want to find from here to here. Okay, the wideness of the lip, or we want to find from here to here, or we want to find from the chin distance from here to here. Okay, we want to find from here to here for each of the specimens. So this can be analyzed. All right. So what that means, you need to select which one are you looking for. You may not do to use all for proper analysis. You need to select few ones. Maybe I want to work on 10 only, 10 distances. Okay, maybe I just want from here to here. All right, from here to here, from here to here, from here to here, and from here to here. So I just want few ones. I don't want all of them. So you have to select. All right, you select the one you want. So you don't forget our data set we did at that time. We know how our landmark are, how they are arranged. Okay, you have one landmark, 1, 2, you have 3, 4, 5, 6, all right, 7, 8, 9, 10, 11, 12, and 13. So we have 13 landmarks, don't forget, and each of them have their names. Okay, so we have this one, we have here we have a exocanton, endocanton. We have a nason here. We have this educanton left and right. Also, we have a pronace here. We have a Shellion left, Shellion right. Okay. We have a labella. We have also here this nason. Okay. This tragus. All right. Tragus. So we can pick the one we want to analyze and find the. So let us just see how we compute Euclidean distances first. All right. So you can now use that to compute your analysis, because you're going to give us distance between one point and another point. That's what we are looking for. All right. So this can only be done in pass 2.7, not in 3.0. Don't forget, we cannot perform this in pass 3.0. It has been taken off. So we perform it in pass 2.7. So let's go back to our data now and see how the data look like, our landmark data. So we have, you can see this 1, this 9. Don't mind the arrangement. So you can now rearrange yours. You can copy this one. You can group with your own. Maybe you copy 1 first to another place. Maybe you copy here. For example, maybe we come here like this. You don't want to perform on all. Okay, you want to perform on selected one. You can change the name here if you would like. You can change the name. Okay, so we come here, we want to this 1 to 2. Let's say we go to 2, look for 2. This is 2. All right. So hold down Shift key. Let us select this 3. We have 2. Paste here. Right. So from 1 to 2 to okay. We come again. So you must do this carefully. If you don't want to select use all, you want to use all you want to use all anatomical landmarks, then you don't need to do this. You just select all here. Just select all here. Okay. This way your another landmark stop at 13. All right. So before this one start. So this all don't mind the arrangement. Okay. You know their names out there. You just use them by their names. But the problem is that when it is performed in past, it will not follow your name any longer. It will follow the arrangement. Okay, that is the problem in past. That's why you have to select them. You have to arrange them properly. Okay, in past, when you finished, it will follow your arrangement here, not the way they are given in numbers. No, it doesn't it doesn't see the numbers. It doesn't see if the number exists. Only follow the arrangement here. So it is 1, 2, 3. This is the first one. 1, 2, 3. This is the second one. 1, 2, 3. This is the third one. So you follow this because you have to pick from here to here, from here to here, from here to here, from here to here, and calculate them. Then from here to here, then from here to here, from here to here, calculate them. Then from here to here. So that is how we pick one by one, and calculate each of them, the distances. Okay. So it doesn't know which one is 1 AS, Y9, S9. Or if you use your another anatomical notation, for example, END, okay, or you can have END1, END2, END1, END1. So we can use that one also, but it doesn't see if it exists. So that's why you have to first do a grouping, arrange them in proper order, so that when you know that it follows in the same pattern. All right. So let's see how it is computed. Then we can stop there for now. All right, let's go to pass 2.7. Okay. New. Don't want to copy. Let's copy the data. Okay, let's just use this to see. Let's see what I'm talking about. We only use 1, 2. We only have 1. If we use this, we only have 1 distance. I don't want to use this. So let's use this. Oh, okay, let's stop at okay, let's stop at this. We have 1, 2, 3, 4. So we have 4 distances. I want to calculate. Okay, let's say this is 4. Okay, let's go to the past. Okay, let's new. Okay. Paste. All right. Select all. So now we want to have selected all. This is what we pasted here. So we now go to geometry. Okay, you see distance from landmark data. This is EDMA. This is Euclidean distance matrix. Click here. We are dealing with 3-dimensional. Don't forget. So you have to put 3 here. If you are doing 2-dimensional, you have to put 2. We click on OK. Can see it's calculated now. All right. So this you can see what I'm saying. So you say 1 to 2. It's seeing it. It's looking at these columns, not your own data name. It doesn't look at those names. They don't exist as far as past is concerned. So it doesn't need to see them. But because you are calculating a formula using the formula, so you can see here the first one, 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4. So you have calculated all of them here. So you can print them out. You can copy them out. Okay. You can copy them out. Just select all and copy them out. Or you can log transform it. If you don't want to use this direct one, you can log transform it by selecting all. Just select all. Select all. Then click on transform. Log. Okay. So it's log transformed now. Then you can now use this one. This one is 1 point something. This one has reduced to, see the same thing, but you just have to reduce the normalize the or transform it so that it can be easy to compute. Can you see 1.7, 2.8, 3 point something? You can see This one is giving you different sizes. We have 2.0, 2.0, 2.2. So it's a minimum. It's easy to calculate here right now. So you can copy this one to your work and analyze it better. This is what they call Euclidean distances. You can analyze it. It's also a feature that you can use to calculate or classify it. If you want Hall, just paste Hall here, then calculate it, then go and paste it in your past. It become a new feature for you. You can have up to 6,000 features for classification purpose. It is very nice. It is very good. It is good. You can use any machine. You can use machine learning to do that, to classify them. Okay, you can use SVM. Okay, to classify your this thing. You don't necessarily you must use LDA only. You can use SVM. You can use Neural. So this is how to calculate your Euclidean distance. So for now, we're going to be putting an end to this lecture for now. Today. So we have covered majority of our points we have mentioned here so far. So if you have any questions you want to ask, you want me to answer, you can post them there. If you anything you want to learn more that is not mentioned here, you can let me know. I will also post them there for you. All right. If you like the lecture, you can please try. You can click on thumb up for me. Okay. You can rate it if you like the lecture. You can rate. All right. I would love to see your rating. At the same time, if you have anything you want to ask or you want me to add to it, let me know. I will do that. So this one is enough for you to do a proper analysis and a proper research in morphometrics in 3-dimensional. Thank you so much for your listening. Thank you so much. I really appreciate it. Thank you.